Okay, so today we're starting a new chapter, and as we are transitioning to a adaptive pause right now, I just want to talk about a few things. So, since you guys are all getting the lesson in the Zoom call, now I'm going to try to make these videos go a little bit quicker, and we're going to kind of skim over some more stuff. We'll still talk through the example problems, but we're going to spend a little less time on vocab, talking about the vocab and that introduction stuff. Because you'll have an opportunity to listen to that during the Zooms and then copy the notes from these videos as well. So, that being said, the goal of 4.1 is dealing with classifying triangles, and this is one, I don't want to say it's my favorite thing we do all year, but triangles are just a wildly interesting shape, and we'll get into more of why that is and what makes them so unique as we go on. But anyway, so the goal for today is for you to be able to identify and classify triangles by their angle measures and to be able to do the same with their side measures or side lengths. So we have a whole slew of new vocabulary today. I'm just going to brush over it. All the definitions are there in general. So an acute triangle has 3 acute angles. An equilateral triangle has all the angles are equal to each other, so they're all 60 degrees. Obtuse triangles have 1 obtuse angle or 1 angle greater than 90 degrees. A right triangle has 1 right angle. You can't have 2 right angles or else it wouldn't be a triangle. Equilateral triangle has all the sides being the same length. Isosceles triangles have 2 sides that are the equal length, 2 sides and only 2 sides, because if it has a third side that's the equal length, then of course it's going to be equilateral. Scalene triangles have side lengths that are all different. Okay, so now we have some lovely pictures, beautiful examples. We shall continue. All right, so our first task is to classify the triangle as acute, equilateral, obtuse, or right. Gross. Sorry, email. Don't want to deal with that right now. So, acute triangle, all angles are less than 90 degrees, so smaller than 90 degrees. So they're just teeny tiny little angles. Equiangular means all the angles are the same, and obtuse means that the angles, at least one of the angles is greater than 90, and then a right triangle, one angle has to be 90. So right away, no angles are 90 degrees, no angles are bigger than 90 degrees, so it can't be obtuse or right. Equiangular, all the angles are the same, and all the angles are smaller than 90 degrees. So here's the tricky part. It is both acute and equiangular. Now, any equiangular triangle you have, though, is also going to be acute. And that's by the nature of it. So all triangles, the 3 interior angles, they always add up to equal 180 degrees. So angle 1 plus angle 2 plus angle 3 is always going to equal 180 degrees. So anytime you have an equiangular triangle, it's going to be 60 plus 60 plus 60. And so for it to be equiangular, all of them have to be smaller than 90 as well. So the answer I would give for this one is equiangular, just because it's more specific. So I would say it's equiangular. You could say acute and you wouldn't be wrong, but equiangular would make you more right. All right. So classify the triangle as acute, equiangular, obtuse, or right. So same deal as before. For it to be acute, all the angles have to be less than 90. We have a 130 degree angle, so it can't be that one. The angles aren't all 60 degrees, so it can't be that one. We do have one obtuse angle, and we have no right angle, so it must be obtuse. And once again, you can't have an obtuse and right triangle. It's one or the other. Because if we had an angle that was greater than 90 and an angle that was 90, So 90 plus anything bigger than 90, so 91 would be the first one, is going to equal 181, or it's going to be something bigger than 180. And if the interior angles add up to more than 180 degrees, then it cannot be a triangle, because the interior angles of a triangle always add up to 180. Like this 130 plus 20 is 50, 50 plus 130 is 180. So they always add up to equal that 180. All right, so we have an architecture question. The frame of this window design is made up of many triangles. Classify triangle A, C, D. Okay, so triangle A, let's grab this one. And let's go for slightly bigger. So ACD is going to be this little triangle right here, or not so little triangle. They have no dimensions for us, so I'm just going to say little because it's on a little screen for me. All right, so we need to classify it as acute, equiangular, obtuse, or right. So right away, what I see is this angle right here, this angle ACD spanning right here. I believe that to be obtuse, because if I was to make a 90-degree angle, it would kind of cut right in there somewhere. So it looks like it's bigger than 90 degrees. So I'm going to say this one's obtuse. I know it's not equiangular because they're not all the same. ACD is clearly different. And I don't see a right angle, so I don't believe it can be a right triangle. In the Zoom, we'll talk more about my anger towards this section, and more so the textbook in general, in that they like to play that game where they try to trick you all with like, oh, it looks like a right angle, but it's not labeled a right angle. But then they go ahead and put questions in like this where they don't label anything. So one could argue, well, none of the angles are labeled, so I can't classify by the angles, which would be a totally fair point. And if you ever see anyone responsible for making this textbook, please, please, please let them know that. So the frame of this window design is made up of many triangles. I thought it said how many, and I was like, those answers don't make sense. So triangle ADE is the one we're classifying now. So this is another great example of my anger towards the textbook company. So once again, we have a triangle. It appears to be a right angle. We can't say it is because it's not. And the textbook would be real quick to judge you guys on a test for doing the same thing that we're about to do. But the correct answer is that it's a right triangle. So we're supposed to assume that the window is squared off at 90-degree angles. I'm getting angry. Sorry. So essentially, since it appears that there's a right angle, we're saying it's a right triangle. We honestly don't know for certain because they refuse to label anything. Granted, most windows are square and 90 degrees, but not all of them are. There are goofy shaped windows, and so it wouldn't necessarily be 90 degrees. It could be slightly obtuse or it could be slightly acute, but the correct answer is right. As always, the textbook's going to try to trick you with stupid stuff like this. I'm not, though. So if it looks right, it's right. Okay? If it's one of those ones where they're going to try to trick you, I will let you know, hey, make sure it's classified as right. If it's not, then you can't assume it's right or something like that. We'll talk through it if it's one of those tricky ones. But in this case, it looks right, so we're going to call it right. All right, so classify triangle ACD as acute, equiangular, obtuse, or right. So let's go ahead and start with the back end of this. So if it's a right triangle, there would have to be a 90-degree angle here. There is no 90-degree angle. We have a 40, an 80, and a 60. So therefore, it can't be right. By the same merit, for it to be obtuse, we'd have to have one angle bigger than 90 degrees, and we don't have one present. We have a 40, an 80, and a 60. So it can't be obtuse. Equiangular would mean 4. Triangles have 3 angles. Equiangular would be 3 60-degree angles. We do have one 60-degree angle, but we don't have 3. So it can't be equiangular, which leaves us with acute, which would mean all 3 of our angles would have to be less than 90 degrees. 40's less than 90, 80's less than 90, and 60's less than 90. So it is acute. And we have another happy classified triangle. Okay, so that was classifying triangles by angles. Now we are going to classify them by their side lengths. Be prepared, because I might get angry at this section too, due to their not so awesomeness. I tried to delete the problems that really angered me, because they're dumb and don't give you enough information, but I may have missed one. I'm not 100% sure. All right, so we have equilateral, all the sides are the same. Isosceles, 2 sides are the same. And then scalene, no sides are the same. All right, so we're back to our architecture problems. So the frame of this window is made up of many triangles. Still, they want us to classify triangle A, B, C. A, B, C. Okay. So here's my issue here. I'm fairly certain all these sides are the same. I believe it's equilateral. But once again, they didn't give us enough information. And now you can argue it different ways, and I'm trying to think if there's a way. No, because they don't give us anything. Once again, we're assuming if this is square, then it would be equilateral, but they don't give us that information because the textbook is stupid. I shouldn't say that. It's not stupid. It's frustrating, and it frustrates me. But so this one I would say is equilateral, even though we don't technically have enough information to solve it. Okay. These are problems that I like. These problem-solving questions where we kind of have to work through everything, and then we get to determine whether it's equilateral, scalene, or isosceles. So let's start by reading this question slowly. If point Y is the midpoint of Vx, so they're saying point Y, which isn't really shown, but I'm going to call it somewhere in there, is or no. So they must be saying this is point Y, which they didn't really do a great job of labeling, but I feel like you guys have probably heard enough of my ranting for today, so I'll leave it at that. The Y is just nowhere near it. So if point Y is the midpoint of Vx, which if it's the midpoint, that means that this side length and this side length are the same. Classify triangle VWY. Okay, so we're supposed to be classifying VWY. So this triangle here that I'm coloring in yellow, or I'm attempting to, but I'm coloring outside the lines. So we're classifying that yellow triangle as equilateral, isosceles, or scalene. And then we're supposed to explain our reasoning. So, first things first, we have to determine, well, you know what? Let's label everything we know first. So, WY is 3 units. So WY, so this line here is 3 units. And that's given in the question. And then we also know that Vy is equal to Yx, and added together, they equal 8.4 units. So if I know Vy plus Yx equals 8.4, and these two are the same, then I could say each of these equals 4.2. So I would say this is 4.2 and this is 4.2 units. So now that I know all of my side lengths, I can determine that that yellow triangle would be scalene. So as far as explaining your reasoning, at some point we may see proofs kind of make a comeback here. Theoretically, if we were to do a proof for this, I'm just going to kind of walk you through what it would look like, because I think it would be a good practice, knowing that they will be back at some point with vengeance, naturally. So we have our statements. Reasons. So I would start off, if I was going to write this proof, I would say, based on the picture, VW equals 4.5, and I would say WY equals 3.0. I would say that's given. My second piece, I would say that Vy equals Yx, and that would be definition of midpoint. Then from there, I would, depending on how many steps you want to take, I would say 2. No, we're going to skip that step because it just gets drawn out. So I'm going to skip like my substitution and then plugging in and saying 4.2 equals Vy. So I'm just going to say 4.2 equals Vy. And that is, I'm going to say substitution, just because we would have had to substitute and then we would have had to do division property, but we're just going to say substitution for this. And then my final step, I would say triangle VWY is scalene. Reason, definition of scalene triangle. All right, so that's how you'd kind of write a 2-column proof for something like this. Like I said, I know that's not in the directions, but I feel like the additional kind of showing you guys who take the time to watch the video how that would be done is going to be beneficial to you in the future, whether it be this year, next year, 4 years, I don't know. So if point C is the midpoint of line BD, then classify triangle ABC. So triangle ABC is this one here that I'm going to color yellow again. The reason I color these is because it's easier for me to see what I'm trying to classify if I color it in. Personally, I have a rough time, even sometimes with the outlining. So for me, it's easier to just kind of color it in, which is something that you guys should feel free to do as well on your tests and quizzes. It might be beneficial to you. So we're classifying it as equilateral, isosceles, or scalene. So The key information here is saying that C is the midpoint of BD. So we have to divide this 3.4 in half because we know this line segment and this line segment are equal. So if we divide 3.4 in half, then we would get 1.7 for each of these side lengths. So since we have side lengths of 1.7, 1.2, and then this one over here would also be 1.2 because we have these little hash lines saying that they're congruent. So we have two side lengths that are the same. So it must be isosceles. If we have two side lengths, only two side lengths that are the same, then it would be isosceles, because equilateral would be 3 sides, isosceles would be 2, and then scalene would be a 0. Okay. Find the measures of the sides of this isosceles triangle KLM with base KL. Okay, so once again, this one's kind of tricky because they don't label which ones are congruent. This side and this side are congruent, and the way you can tell that is because they do tell you that the base is KL, and so your base is always going to be that side that's not congruent. And there's a drawn out reason for that you'll eventually learn, probably your junior or senior year in high school. But I'll give you guys kind of the brief Cliff Notes version of it. And the reason is when you can use trigonometry and fancy calculations to determine side lengths based on angles if you have these angle theorems down. And so you're trying to debate if I should even go into this. So on isosceles triangles, your angles that are across from your side lengths that are the same, they are always the same. And so since this obtuse angle is your different angle, that means that the side directly across from it must be different, or your varying side length. So it's the one that does not belong, essentially. So anyway, since we know that these two side lengths are equal to each other, what I would do is I would write 4D minus 13 equals 12 minus D. And then I can solve this equation for D to find my D value, and then I can plug it back into all three of those equations. So I'm going to start off by adding D to both sides. I'm left with 5D plus 13 plus 13. So 5D equals 25. We divide by 5, and we're left with D equals 5. So D equals 5, but we're not quite done yet because we have to take this value and plug it back in to all three of those. So I'm going to write my final answers in green. So the side length of KL would be D plus 6, and D equals 5. So I would say 5 plus 6 equals 11. So that would be my final for this one. For LM, it would be 12 minus D, or 12 minus 5. So that side length would be 7. And then my last one would be 4D minus 13, with D being 5. So 4 times 5 is 20, minus 13 would be 7. And this checks out because we have side LM and side KM are supposed to be congruent to each other. So that works out perfectly. Yay. Moving on. Okay, so this is the hardest problem on here, in my opinion, other than the ones that didn't have enough information to be answered. And the reason for that is they don't give us a picture. And I believe the pictures are key to helping us understand. So they want us to find x and the measure of each side of an equilateral triangle, ABC. Let's see if there's a triangle tool in here. Nope, there's not. So we get to see my drawing skills. So triangle A, B, C. Oh man, that was actually not bad. Oh, I'm actually moderately proud of that. So we have A, B, C. and it's equilateral. That's important. And they tell us that AB is 6x minus 8. 6x minus 8. BC is 7 plus x. And then AC is 13 minus x. Okay, so since this is an equilateral triangle, we know that all three sides are the same. So I can choose any two of these and set them equal to each other to find my x value. So what I'm going to choose, I'm going to choose to use AB and BC. Like I said, you can choose any of them. It's not going to make a difference. Those are just the two I'm choosing. So 6x minus 8 equals 7x plus 7 plus x. Okay, that would be helpful to write correctly. 7 plus x. Okay, so I'm going to go ahead and solve this. So minus x from both sides, minus 1x. Then I'm going to add 8 to both sides. So I'm left with 5x equals 15. I divide both sides by 5, and I'm left with x equals 3. Okay, and as before, we're not done yet because we have to plug this back in to all three sides. Now, some of you might be thinking, why do we have to plug it back into all three sides when we know all three sides are the same? That's a good point. So you could really get away with just plugging it into one. Personally, I like to plug it into all three just to make sure I have the answer correct. So I'm just going to plug it in mentally for all three. So x being 3, 6 times 3 is 18 minus 8, which would make side AB 10. 7 plus x, x being 3, so that would make side BC 10. And then 13 minus x, which x is 3, so 13 minus 3 would be 10. So this checks out. X equals 3. All my sides equal 10. I'm just going to say units for good measure. And that would be that. Okay, so minus my ranting and raving, this ended up being a pretty long video. So I kind of apologize for that, but I kind of don't, because I believe you guys will be set up